Hello students, welcome back. Now let's go back to section 5 for the last problem. And this problem is not that simple. The salaries of junior executives in large corporations are normally distributed approximately. A pending cutback will not discharge those junior executives within 4,900 of the mean. If this represents the middle 80% of the salaries, what is the standard deviation? This problem is very different. This problem has mean and standard deviation given. This problem, again, mean and standard deviation. This too gave you the mean and the standard deviation. This problem here gave you neither. You don't know what the mean is. You don't know what the standard deviation is. Moreover, you have to find out the standard deviation. How do you do that? Well, the best way to understand this kind of problem is to draw a picture. Actually, that's the only way to understand any kind of problem, as a matter of fact. But this kind of problem, particularly so, because if you draw the picture, things will begin to make some sense from that point on. Without the picture, it's really hard to see. Okay, let's go to drawing mode and then let's draw some pictures. Okay, here's a normal picture. And then we have the mean, but the problem is we don't know that. And then we have one end. And then we have the other end. We don't really know that either, but the problem gave you two pieces of critical information. One is from here to there, 4,900. And then again from here to there, 4,900. So I don't know x value, and also I don't know the mu value. But x minus mu I know. That differs by 4,900. Make sense? Okay, let's go back. So z-score is x minus mu over sigma, right? And I don't know what x is. I don't know what mu is. But I know what x minus mu is. It's 4,900. That's the difference. And let's see. From this one, negative 4,900, because x1 minus mu, this one is left-hand side, so this is less, and then over sigma. If you want to use this one, then positive 4,900. Which one do I prefer? Well, I decided to use the left-hand side one. This one. Okay, why did I decide to do that? Well, this problem says %80 in the middle, which means 10% here and then 10% there. So 80% in the middle here. That means here I have 10%, here I have 10%. Make sense? So I have 10% here, and then 10% over there. I'm focusing upon the left-hand side, so I have to look at this. If I focus upon the right-hand side, I have to look at that, but I decided to use the left ones. So, can you make things out of this picture now? Z-score is x minus mu over sigma and minus N2 over SD. I don't know what x is, I don't know what mu is, but x minus mu, I figure out, is negative 4,900. The problem says so. And as for the z value, that's going to be the 10th percentile. 10% here, 0.1 here. So what is this z value? By looking up the z-score, I can figure it out. What is this value? I can find out. And that'll give me an equation to solve. That's an equation. I know find a sigma. Numerator I know, and the other side I can look up the z-table and find out. I already have everything except for sigma, so for sigma, then that's going to be the answer. Okay, then what is this z-score? Well, let's get out of this drawing mode. And here is the z-table. Okay, let's go find out 10th percentile. Closest to 10%. 0.11, 0.1003. That's the closest. That's the closest. So I will find out something closest to 10%, and this one is the closest, 0.1003, and is coming from negative 1.2 column, and this is 8. Negative 1.28. Negative 1.28 is my z-score. Alright, it's coming from negative 1.2 column, and then coming from 8 column. Negative 1.28. Remember that, negative 1.28. Negative 1.28 is my z-score. Alright, negative 1.28. So, z is negative 1.28. But that's end minus center over SD. I know neither x nor mu value, but I know what x minus mu is. It is negative 4900. All right, here we go. We have an equation. We can solve it. Multiply sigma to both left-hand side and right-hand side. Negative 4900 is equal to negative 1.28 sigma. And then divide by negative 1.28. Negative 4900 over negative 1.28. And if you run your calculation, then you're going to get what you want. What is this value, by the way? Negative minus negative. Negative, negative, so it's going to be positive value. And 38.28, approximately speaking. So this is 38, 30, or even 3800. I mean, nothing is accurate in statistics, so I'll just change everything into approximation. And I guess that's about it. Let me show you the full solution. Here we go. The middle 80%. So middle 80%. So by symmetry, we have 10% here and 10% there. Usually, I like to work with the left-hand side endpoint for normal distribution. Sometimes I use right-hand side, but normally I use left-hand side endpoint. And look up the z-table, and I got negative 1.28. Here I use Mathematica, so I have negative 1.28155, but look up the z-table, and you're going to get only about this much, negative 1.28. That's the z-score. So, z-score is negative 1.28, x minus mu over sigma 4900 over that. Here I decided to throw away all the negative signs because, hey, we want positive number anyway, so why do we bother with all those negative? That's perfectly fine. And then divide, and then it works out. $38.23, so about $3,800. So $3,800, approximately speaking. That's the standard deviation. All right, how do you like this problem? Standard deviation problem. Well, let's make a confession. I've been teaching statistics since, I don't know, in college level from 2001. Not every semester. I taught in and out many times. It goes way back, but I've never written the standard deviation computation problem in the exam. I do write these kind of things in homeworks here and there so that I cover the minimal, but as for exam level, too complicated, and also there are so many other important problems. And that's why I separated lots of problems from the rest of the problem set. And then, as I said before, many people may end up skipping this last video. And indeed. But all the other problems about the mean especially, they're all important. So pay attention to all those.